Stress, strain, and Young's modulus. How do they work? Stress is force over area, or sigma. Strain is delta L over L0, which is epsilon. Young's modulus Y is sigma over epsilon naught. Here's the example. You have a mass of 1,000 kilograms. It's sitting on top of a column 4 meters tall and 1 centimeter by 1 centimeter, and as a result of that pressure, it squishes down 2 centimeters. What does that tell us about the material that this is made out of? The force compressing it is mass times gravity, 9,800 newtons. The area, the cross-sectional area that has to support that weight, is 1 centimeter by 1 centimeter, or 10 to the negative 4 square meters. As a result, sigma, force over area, the stress, is 9.8 times 10 to the 7th Newton per square meter, also called Pascal. Meanwhile, delta L is 2 centimeters, ignore the minus sign, 0.02 meters. L0 is 4 meters. So the strain, delta L over L0, is 0.005. No units on the strain. The meters canceled out. Which means that Young's modulus, stress over strain, is 9.8 times 10 to the 7th pascals over 0.005, and we get 1.96 times 10 to the 10th pascals. So Young's modulus tells us how hard it is to stretch or compress a material. It measures how squishy the material is, or how stiff it is. One more thing, you can take the formula with stress over strain equals the modulus and rearrange it into force equals that times delta L. That might look familiar. It's a spring constant, Young's modulus area over length.